Hello, so today's question is about explosions. We're going to be doing a worked example of a past paper question. So the past paper question goes like this. The figure below shows a skateboarder jumping forwards off his skateboard. The skateboard is stationary at the moment the skateboarder jumps. That stationary comment is key. That tells you it's an explosion question. The skateboard moves backwards as the skateboarder jumps forwards. Explain using the idea of momentum why the skateboard moves backwards. Well, this is clearly all linked into the idea of the conservation of momentum. So this is the way that I would put it. Is the momentum before jumping, or jumping off the skateboard, is equal to the momentum afterwards, or after jumping off the skateboard. So that's just applying the law of conservation of momentum to this particular event. Now, as we know, in the question it says that the skateboarder and the skateboard are both stationary. So before jumping, the total momentum of both the skateboard and the skateboarder is zero, is equal to nothing. Remember, V equals 0, so therefore P has to equal 0. And then we go on to talk about after jumping, and this is where the explanation of the backwards motion of the skateboard comes in. So after jumping, the skateboarder has a momentum in the forwards direction. And this is given to you in the question. So take a look at the question, it's given to you in the forwards direction. And let's just take a quick look at the diagram just to show you what it's talking about. So essentially it's saying that the skateboarder is moving off in that way. So, if that's the case, then the skateboard has to have an equal momentum, but in the opposite direction. And in this case, it's in the backwards direction. Remember, this question has stated the word backwards, so you have to use it in your answer. Okay, now then, let's see if we've got full marks for that. So this is a 3-mark question. We get 1 for the conservation of momentum. We get 1 for stating that the momentum is 0 at the start, and we get 1 for using that to explain why the momentum is in a backwards direction for the skateboard. So moving on to the next question. The mass of the skateboard is 1.8 kilos, and the mass of the skateboarder is 42 kilos. Calculate the velocity at which the skateboard moves backwards if the skateboarder jumps forwards at a velocity of 0.3 meters per second. Okay, so like in my previous video, what I'm going to do is I'm going to split my answer into 2 halves. I'm going to talk about the skateboard and the skateboarder. On the left-hand side, I'm going to declare M1 and V1 as being the mass and velocity of the skateboard, and M2 and V2 as being the mass and velocity of the skateboarder. We know we've got 1.8 kilos as the mass of the skateboard, which is just up there in the question. I've just underlined that for you. Okay, and then in the other half we have 42 kilos is the mass of the skateboarder multiplied by 0.3 meters per second. Algebraically we can rearrange for V1, and that would look something like this. V1 equals 42 multiplied by 0.3 divided by 1.8, which gives us 7 meters per second. And that's our answer. Do we get full marks? Well, stating the correct answer gives you 3 marks for starters, but also things like substitution gain you little extra marks as well. So if we've correctly substituted here and we've rearranged there and we've got the correct answer, we get 3 marks. Now, the algebraic method isn't everyone's cup of tea. If you want to do it in a slightly more basic method that's easier to remember potentially, then you could do it this way. So this is an alternative method. And it's essentially the same calculation but with an extra step. This way we calculate the momentum of the skateboarder first and then calculate the velocity of the skateboard after. So we can work out the momentum of the skateboarder as follows. So, momentum of the skateboarder is equal to its mass multiplied by its velocity. So in this case, it's 42 kilograms multiplied by 0.3 meters per second, which gives you a momentum of 12.6 kilograms meters per second. Now, the benefit of this particular method is that if you do up to this point correctly and you identify 12.6 meters per second as the momentum of the skateboarder, you will get 2 marks. And that is even if you mess up the velocity of the skateboard afterwards. So if you calculate the momentum for one of them without knowing how to get to the velocity, that gives you 2 marks. But the velocity of the skateboard is then equal to the momentum of the skateboarder, which is 12.6 divided by 1.8, which gives you 7 as before. And that would, of course, give you the full 3 marks. So, hopefully that makes sense. That is a question that caught a lot of people out previously, so I'm hoping that it's starting to make a little bit more sense. Now, I'm Mr. Bonser. I'm looking rather thin in this diagram, which is fantastic. I've lost weight this holiday. Hope you enjoyed the video. Bye-bye.